Welcome to RGES Pre-Algebra Lesson 33B. We're in Psalm 103, verses 1 through 5. It says, "Bless the Lord, O my soul, and all that is within me. Bless his holy name. Bless the Lord, O my soul, and forget not all his benefits, who forgives all your iniquities, who heals all your diseases, who redeems your life from destruction, who crowns you with loving kindness and tender mercies, who satisfies your mouth with good things, so that your mouth is renewed like the eagle's." Wonderful verses. Bless the Lord, O my soul. That's the bottom line, right? Bless his name. And he says that we want to do this. He says it twice. Bless the Lord, O my soul, all that's within me. Bless the Lord. Bless his name. Right? So we want to be wholehearted in our praise to him with all our heart, without reservation, but what about this? It's talking about trust and confidence in him. The psalmist urges us to remember his goodness. Look at all these verses. Remember who he is and what he has done. Listen again. Don't forget his benefits. He forgives you, your iniquities. He heals your diseases. He redeems your life from destruction, from the pit. He crowns you with loving kindness and tender mercies. He satisfies you with good things. Wow, what is the Lord to us, right? Remember, pause to remember. Wow. How many times, what testimonies do you have in your life? How many times has he forgiven you? How many times has he showed you grace and mercy and kindness, not treating you as your sins deserve, not having to reap the full weight of consequence for the things you have chosen and the wrong ways you have acted and the bad attitudes that you have had. Wow, he is merciful. He's forgiving. He's generous. He's kind. He reaches out towards us. The Lord is for us and not against us. And because of that, I can lift my cry to him. I can lift my heart and thank him, bless him, thank him, express gratitude, be grateful. Right? My heart towards him is good in response to his heart towards us, which is good. Lord Jesus, open our eyes today. Open our eyes to see your goodness, your kindness, your grace, your mercy, that even when life is difficult, you're calling us back to yourself. You're calling us to look to you and respond to you. Thank you, Lord. You are gracious. You are kind. And we will declare it with all our hearts today in Jesus' name. Amen. I did notice sometimes when I'm writing and thinking at the same time I write the wrong word. Let me fix that last word there so it makes more sense. There we go. I got a little distracted. Okay, so now what we want to do is let's go ahead and do our answers to 8.42 and 8.43. These are the very last concepts we'll teach this year. And of course, we've already taught them. We'll just review them here. Okay, the basic principle about volume is what? You want to take the area of the base, this is your basic idea. Take the area of the base and multiply it by the number of stories or the number of levels high you go. That would be the area of the base, and you multiply it by the height. That's the overall concept of volume. So if I'm looking at a cylinder, I would take the area of the base, which is what? That would be area for a circle. Whoops, let's go ahead and put volume. Okay, would be pi r squared times the height. So from that point, you're just going to plug in your values, and your answer should be 141.3 cubic inches, 75.36 cubic inches, 18.46 cubic inches, 942 cubic inches, 2,373.84 cubic inches. I trust you're using your calculator for these. And finally, the last one, which you probably could do in your head, and that would be 3,140 cubic inches. Now, let me say volume is always, by the way, in cubic units. Right? That means like if it were inches, it would be inches to the third power, right? Or cubic inches. All right, so let me see if there's anything tricky in any of those. Okay, so for the first one, you would be doing r squared would be 9 pi r squared, right? So then that'd be 9 pi times h, which is 5. That'd be 5 times 9 is 45 pi. And then you just multiply that by 3.14. I actually, you're going to want to give your answers in the same units the book does, but for me, if I just said the volume equals 45 pi, I'd be happy enough, okay? And then calculate it into the number at the end. All right, so hopefully you understood those. Again, as always, if you still have questions, please text. So let's go on to 8.43, which is the volume of a cone. Okay, so how does this formula differ? When I said before you take the area of the base and multiply by the height, it had an assumption in it, and that is that you're going up, your height is going up always at right angles, and so it's going to be consistent. Your top, the shape of the top and the shape of the bottom of your three-dimensional figure. Sorry for my lousy diagram. I wasn't focused on thinking about that as I went. But anyway, so it's going to be the area of the base times the height. That's the overall thing, presuming that the top and the bottom have the same shape. Now, when I have a cone, what I have is something like this, where I have the shape of the base, but it goes up to a single point. Now, if it went up the same so that the top and the bottom were the same, that's the cylinder, right? But this is obviously got to be less. A cone is less than the cylinder, and the question is, when it comes to a single point, how much less? It's only a third. This shape on the left, the volume here is only 1/3 the volume here, okay? And that's the same as when we think of a pyramid, anytime it comes to a point. So there's my formula. And the area, the base of a circle, again, is pi r squared times the height, divided by 3 because it's coming up to a single point. So using that formula then, your answers should be 235.5 cubic inches, 37.68 cubic inches, 593.46 cubic inches, 19.63 cubic inches, number 5, 188.4 cubic inches, and number 6, 1,507 cubic inches. Let me do one of those for you, and I think I'll do number 5. If R equals 6 inches and the height equals 5 inches. My volume for the cone is going to be the area of the base, pi r squared, times the height, divide by 3. I'm going to plug in for everything but the pi here. That would be 6 squared, which would be 36 times 5, divide by 3. That would be 36 times 5 is 180 over 3, still times pi, and that would be when you divide 60 pi. Now that actually for me is a very good answer, but to make it into, you do that last step to make it into a decimal answer, and that would be taking it and multiplying it by 3.14. So again, I like the method of just going ahead and doing all my basic arithmetic. By the way, here I could have, rather than multiplied, I could have also canceled and done 12 times 5, and that's also 60 pi. So I like you to get to the point you're just doing your algebra. I would call all these steps doing my algebra, and this last step, the calculator step, if I need it. All right, and then finally the last thing would be sharpening skills 6 through 15. We're just one more time doing our formulas. I like you to think about the formula rather than just memorizing them all, but whichever works best for you, truly. It's just a question of wanting you to understand it, but whatever works best, one way or the other, you do it. Number 6, V equals 1/3, or pi r squared h, or I could say pi r squared h over 3, same answer. 7, A equals pi r squared. 8, surface area SA equals 6e squared. 9, V equals 1/3 LWH, or LWH all over 3. Trapezoid number 10, A equals H times the quantity B1 plus B2 all over 2. 11, V equals LWH. That would be multiplication, right? 12, V equals pi r squared h. 13, C equals 2 pi r, or pi d. 14, SA equals 2BL plus S squared, or, yeah, I would just go with that one. Okay, where you've gone ahead and reduced your 1/2 times your 4. So that's the best answer for the square pyramid. Okay. Remember what we have is we have 4 triangles, and each triangle is 1/2 base times L, meaning slant height, and then the base, which is S squared. And finally, V equals E cubed. So you should be really squared away with these by now. If you have any question at all, what's the answer? Text me. Now, what we're going to do for this lesson and the next 2 lessons is that you are going to, we're going to review for the exam. Our final exam will be over chapters, find that. So our final exam will be on these 4 chapters. The best place to review, the first place to review, would be look at all your quizzes and all your tests. Do it 1 chapter at a time. So today we're going to focus on chapter 4. Monday, we're going to focus on chapters 5 and 6, and next Wednesday, the tape will focus on chapter 8. So then for your homework, there's no new homework at all, but I would suggest that what you do is you go to chapter 4, you watch the tape. You might want to watch it more than one time to get your mind remembering those things, and then you would go back to every quiz and every test related to chapter 4. Make sure you can do those. If you need more practice after that, then you want to go into the chapter in the book and glance over and review several problems out of each section. But many of you will find, because math builds upon itself, that this review, along with reviewing your quizzes and tests, will be enough review for you. I expect you all to be able to do well on this. And it will also show you what's still weak. What you're still weak about, make sure you go back and review that section one more time. All right, here we go. Let's start the review on the next page. The first idea is sign numbers. So we care about when we add or subtract sign numbers, and we care about when we multiply or divide them. The best thing starting place to think about when you're thinking about adding or subtracting sign numbers is the number line. So let's say I want to add 2 positive numbers. I'm going to go there and there, and my answer will be positive. And it will be the sum of the 2 numbers. What do I mean by that? Well, if I have plus 4, or maybe I just would write 4 plus 7, okay, that's just going to be 11. I take the sum of the values, 4 and 7 is 11, and it will be a positive. Okay, and of course, if I just wrote 11, that means positive 11. And we knew that. Okay. Now, what if I had 2 negatives? If I had -3 and -7, I'm going in the negative direction twice. So my answer will be negative. 2 positives is a positive, 2 negatives is a negative, but I'm still summing because I'm going in the same direction both times. So if I have -3, -5, I'm going -3 places and -5 more places. Altogether, that will be -8. Now, I would also write that -3 plus -5, and I mean the same thing. So when I see this, I'm thinking this. Or some students like to do it the opposite way. When I see this, the top line, I'm thinking this. It doesn't matter. You're thinking the same thing. I'm saying I've got the same signs being added together. Same signs being added together. So I will go in the same direction. So I have to add those values, 3 and 5, and I'm in the negative direction. Same signs going in the same direction, 3 and then 5 more, and I went in the positive direction. See how that works? Okay, now very important idea, because some students in early algebra get this confused. Neither one of these, this does not mean this. Okay, -3 minus 5 does not mean that. Why? This, when you have a number next to a parenthesis, that means multiply. This, where you have a sign, you have the number, and next you have a sign, that means add them or sum them. Okay. Okay, we are combining. This is an add or subtract, depending on how you want to look at it. And why do I say that? Why is that? I don't want that to be confusing to you. Adding and subtracting are the same thing, essentially. If I'm looking at it this way, I'm combining a -3 and a -5. So I'll either move in the negative direction, the positive direction. Now let's look at it again. Okay. What if I had -3 plus 5? Notice after the 3, I have a sign. This means I'm combining, so think number line. I go -3 and then the other direction, in the positive direction. So now I need to know what is the difference. To know where I am here when I'm done, I need to know what's the difference. In other words, I need to know what's this distance right there. And I would take that by subtracting 5 and 3. 3 from 5 is 2, and I ended up in the positive direction. Let's do it again. If I have 7 minus 9, I'm going +7 this far, and then the opposite direction, 9. So what did I end up with? What is this place right here? Well, it's going to be 9 minus 7, or 2. This is 2 in the negative direction. I'm to the left of the 0. So this will be -2. If I have 3 minus 4, you're going to go 3, and then the next direction, 4. Oh, I'm sorry. 4. Oops. Let's try to get this to stay still. 3, 4. Where did I end up? -1. Let's do it again. -3, -2. I'm going to go -3, -2. Where did I end up? I went in the same direction both times, -5. Can you see it? Okay. So this is the key to sign numbers, adding and subtracting them. Now notice, as I said earlier, let's go to the next page here. If I had -3 plus -7, I just mean -3 combined with -7. So it's like that's what I was doing when I said -3 minus 7. I still meant -3 combined with -7. These two are the same. They mean the same thing. Okay. So I go -3, -7. Where do you end up? -10. If you had 4 plus a -3. 4 combined with -3 is the same as 4 combined with -3. They mean the same thing. Okay. Pause and make sure you understand that if that's a little bit confusing to you. Some students have a very easy time with sign numbers and others do not. So I want you to really make sure you nail this idea. I go +4 minus 3, where did I end up? A +1. Now, though, I have another idea. What if I say -3 minus a -4? Now that's confusing. I am combining because I have a sign afterwards. But what does it mean to subtract a negative? It means the opposite. So I'm going to say this in my mind. -3 combined with the opposite of -4, or -3 plus 4. What is the opposite of a -4? plus 4. Okay, so this is equal to this. Anytime you have two negative signs in a row, just like that, that equals a positive. So what would that look like? -3 plus 4. Where did I end up? +1. So if I had -3 minus a -5 plus a -4 minus a -7. This means plus. This means plus. And the fact that I have no parenthesis in there tells me I am just combining. So I go -3 plus 5, +5, minus 4, plus 7, something like that, right? Well, that's a little hard to do it that way, so how would I do it? I would rewrite it, the negative as a positive. Remember what a positive and a negative is? When you ever have a positive and a negative together like that, it's a negative. And a negative is a positive. Then I would look at all my positives. I'd look at all my negatives. And 12 minus 7. In the positive direction, 12. In the negative direction, 7. It's going to end up to be a +5. Let me do a couple more like that. -3 minus a -9 plus a -4 minus a +6 minus a -5. Every time I have two signs together, a negative and a negative is a positive and a negative is a negative and a positive. When the signs are opposite, it's going to be negative, and this is going to be positive. So when the signs are both negative, I could say when the signs are the same. If you have two signs together, if they're the same, make it a positive. If they're opposites, make it a negative. Rewrite it. Whoops. -3 plus 9 minus 4 minus 6 plus 5. Combine my positives. Not 9 and 5 is 14. Combine my negatives. -13. And your answer is 1. Now, you might need to review that to make sure you understand those ideas very clearly and they're comfortable to you, okay? And then, of course, review your test on Chapter 4 also. Now, what if I have multiplication and division? That's even easier, and it's based on this idea right here. When I have two signs. Okay? So let's go to the next page. And this is all you care about. I could call it the sign rule. I just used it when I had two signs in a row. Use it now for multiplication and division. If you have the same sign, your answer is going to be positive. If you have opposite signs, your answer is going to be negative. And that's all you care about. So this is really much easier. 3 times a -5. Multiply them like numbers. 3 times 5 is 15. I have, this is a positive, even though, if you have no sign in front of it, it's positive. And so I have a positive and negative are opposite. So it's going to be negative. -2 times -7. You notice the difference in writing. I have the parenthesis right next to the number. as opposed to before when I was combining. And so I know I need to multiply. The signs are the same. It's going to be positive, and 2 times 7 is 14. Here my signs are negative. I'm going to divide, and my answer, because this is positive, right? So you have a positive and a negative. If you have two numbers, you have two signs. One might not be written. A positive might not be written. A negative always must be written. So think two signs, a positive and a negative. The answer is negative. 18 divided by 3 is 6. I have two signs. They're both negative. If you have the same sign, your answer is going to be positive. 21 divided by 3 is 7. I could write the positive or not. If I have no sign in front of the number, it always means positive. If I want it to be negative, I must always have a negative sign. I could put a positive sign or not. All right? So that's enough review on sign numbers. Now, the next idea is going to be evaluating. When I think of evaluating, I want to think of this phrase, evaluate if x equals some number. Then what do? Let's say I say x, let's not do it that way. Say x plus 7. Evaluate this expression, there's no equal sign, evaluate this expression if x equals 3. What do you say? You plug in 3, and 3 plus 7, your answer's 10. Let me do it again. Evaluate this expression if x equals negative 2. Now, rather than plugging in a 3, I plug in a negative 2. This is combining a negative and a positive. I go negative 2, positive 7, right? I'm going to get a positive 5. What else could go wrong here? Well, let's say if I have x squared minus 3. Could I evaluate that? I would have to, every time I see the x, be careful here. You want to plug in that whole thing and put it in parentheses and square it. Because this starts talking about order of operations. We have to be careful what order we do things in. So here I have to make sure that I square first, but I have to square with that negative sign inside the parentheses. Do you see why? Because I'm saying take whatever the x equals negative 2, and square that. So a negative times a negative, same sign is positive, 4, because 2 times 2 is 4, minus 3, and that is 1. If I had xy times negative 3x. That's a good one. Evaluate, this means multiply, because the parenthesis is next to the variable. If x equals 2 and y equals negative 3. What do I have to do? For every x, I want to plug in 2. I'm multiplying, so I'll go ahead and put that in parentheses also. I'm multiplying right here. This means x times y, because they're right next to each other in their variables. So multiply by a negative 3. The parenthesis means I'm multiplying y times this thing, negative 3, and plug in for my other x, times 2. Can you plug in? Okay. Every time I see an x, I plug in 2. So I should have 2 2's up here. Every time I see a y, I plug in a negative 3. That's this negative 3. But this negative 3 was just a constant. Okay, kind of funny. Okay, so what am I doing? I'm multiplying 4 numbers together. Just analyze your signs. I have 2 negative signs. Okay, for every... Okay, so this is one more step beyond what we talked about before. We said if the 2 signs are the same, So I have two signs that are the same, and two signs are the same. Two positives is positive. Two negatives is negative. Two negatives is positive, right? Two positives is positive. So eventually I'm going to get to positives, but that's the long way to do it. Let's do it another way. If you have a new rule that just makes me simplify that rule, is if I have a lot of numbers, if you have an even number of negatives, your answer is negative. Is positive. Whoa, what am I doing? A positive answer. If you have an odd number of negatives, your answer is negative. So here I have an even number of negative signs. So my answer is going to be positive. 2 times 3 is 6, times 3 times 2, which is also 6. 6 times 6 is 36. Could I have written it this way instead? Absolutely. Every time you have a number without a sign, it means positive. Okay, order of operations, let's just mention that. My order of operations, whenever I'm solving an equation, let me say it this way, whenever I'm simplifying an expression, my order of operations is first do the powers, like squared, right? Then do multiplication and or division from left to right. Then do add or subtract from left to right. All right. Square roots. If I have a square root, remember a square root just means what times itself equals 121. If I have no sign in front of it, always make the positive. We call that the principal square root. If I have a plus sign in front of it, then carry the sign to the right. And what times what equals 25? The answer is 5. If I have a negative in front of it, what's the square root of 36? I'll put the negative sign in and do that. And if I have a plus, we read this plus or minus. If I have a plus or minus 16, I put that same sign. Always put the same sign you see in front for your answer. And then what times what equals 16? Your answer is 4. Memorize everything through, memorize your squares 1 through 169. Or I should say, memorize the squares of 1 through 13. In other words, 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49. Okay. That's 7, 8 is 64. 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144, and 13 times 13 is 169, and we'll just stop there. So know these squares. So I could ask you the square root of any of those. So make sure you know these squares. Okay. Square root of 169 is 13. Square root of 100 is 10. Square root of 49 is 7. That's what I mean. Know all those squares. Little bit more review. What if I said 2 to the third power? What is that? Well, it's 2 times 2 times 2. Take the number 2, that's my base, and multiply it by itself 3 times. 2 times 2 is 4, times 2 more is 8. If I have 5 to the third power, that equals 5 times 5 times 5. 5 times 5 is 25, times 5 more. You might have to do it longhand around the side, that's okay. The more you practice these, the more you know them by heart. If I have 4 squared, that equals 4 times 4. 4 times 4 is 16. Okay. What if I had something a little more challenging? What if I put negative 1 over 2 to the 4th power? That means negative 1 over 2 times 2 times 2 times 2. I could say 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. Just like that. But if I said negative 3 to the 3rd power, that's a little tricky. Watch why. Negative 3 times negative 3, this is all the base, times negative 3. When I have an odd number of negatives, the answer is going to be negative. 3 times 3 is 9. 9 times 3 is 27. See how that works? Okay, we're going to need a part 2 to finish our review on Chapter 4.